this is also what we had seen. We had discussed an example of where the input data is going to be 200 MB. What is going to be the block split? It is going to be 128 and 72. But within that 128, you will have multiple records, right? So every record is what is called as an input split, which is going to be a logical division. I hope this is also very clear. This is simple. This is what we have discussed earlier, friends. So now, many times you would see, and even if you look at your example, you would see that the logical records do not fit into the HDFS block. But obviously, because when does the physical split happen? Physical splits happens at the time when you insert a record. I mean, insert a file. When you put in the 100 MB of data, let me open up my notepad. And there we go, and I'm going to say file save as, let me call this as day5. I need to go down to my customers, I need to go down to my Edureka, I need to go down to my Venkat session, I need to go down to my Jan 10, and let me make this as day5.text. Day5.text. Okay, so now if you're having a file whose size is going to be 200 MB, the block split will ensure that it is going to be in 128 MB and 72 MB. When does the block split happen? The block split happens at the time when you are adding a file to the cluster. Okay? And then when you want to read a file, you will need to read records. So you need to identify what is the record split, what is separating multiple records. You will need to read records. And that is what is called as an input split. We have seen this before, it is just that I am re-emphasizing these things. Good. So when I am talking about an input split, yes, let me first add what you had mentioned to the blog. You have already copied it. Okay, good. So when you want to analyze a input split, look over here what I'm having. This will make it very clear for you. So first point, whatever the definitive guide said is correct. So a input split is what is equal, by default equal to a block split. And then internally, what is a separator for an input split? Okay, see here, definitive guide says input split default input split size is equal to the block size and is configurable. True. But once you go inside that, how do I identify what is it? So what I meant by a record split is a part of the input splits, Vinay. Okay, so the logical split per line is different from the input split. Yes, the logical split is what is a record. So once you get that 64 MB, you'll have to loop through it, right? Take this example of my 200 MB of data, Vinay. So if I say 128 MB, in that 128 MB, will I have multiple records? Yes, I will have multiple records. So you will have to go through a record, right? So the input split is at what they are talking about is just one block of reading it, and then you will have to break that into multiple records. In my example, when I am referring to this record split, look at the word, what am I using? I am trying to say it is going to be, after reading a file, you will have to read records, right? So for me, I am considering one record, whatever is the delimiter, /n, that is what is the delimiter. Okay? So now it's good time for you to go and look at it technically. If you're interested in looking at it technically, folks, let's do that. So what I need over here is I need to go down to my C drive. Let's go to the place where I have extracted Hadoop so that I can go down to the documentation and I can show it to you so that your concepts become very clear. So this is again diving a little bit into Java, but then let's do that. So go down to your software. Inside software, I have got my Hadoop. So if I look at my Hadoop and if I look at my, okay, now the challenge over here is, where is my docs? I think it is in etc Hadoop, no? They are not giving you documentation along with this. That is ridiculous. Okay. Let me go ahead. Maybe I didn't download the one with the docs. Let me go back to the share. Here it is. So if you look at the share, inside share, you will look at doc. Inside doc, you would see your Hadoop, and there is something called as API. Okay. Let me copy this path for you so that it will become easy for you. Control C. Will the output of the MapReduce will always be in the form of keyware? Exactly. It has to be keyware. So now if you look at this, double click on index.html. This is what is the documentation, the Java documentation. And if you go down to this documentation, go down to something called as org.apache.hadoop.mapreduce. There you go. In MapReduce, if you go ahead and look at something called as an input format, the class which determines what is how to analyze a record is what is an input format. And let's read this now. See over here. So read these lines. The MapReduce framework relies on the input format of the job to do what? To validate what is the input specifications of the job. It splits the input files into logical input split, each of which is assigned to a single mapper. Okay. So see here, the default behavior of input format subclasses of the file input format is to split the file into logical input splits. Okay. However, the file system block size is treated as the upper bound for the input split. A lower bound can also be set. So this is what Vinay, what the MapReduce, what Hadoop definitive guide is saying. Okay. So you would have, then you have a record reader implementation, how to take input records from the logical input split for processing by the mapper. So please understand this. This is what will make it very clear. Now, inside this, if you look at the input format, there is a file input format. Inside file input format, the default format is text input format. And see over here, this is an input format for plain text files. Files are broken into lines, and either a line feed or a carriage return is used to signify the end of a line. And what are keys? Keys are positions in the file. Remember my offset point example what I took last time? And values are the lines of text. What will happen if one line crosses over? Everything will be covered over here, friend. Got it? Hey, Asif was saying, so what are the difference between input split and block split? The difference over here is the block split is what is going to be used at the time when you are reading it. Okay, you can change the block split at the time when you are writing it, sorry, not reading it. And input split is used at the time when I am reading it. So see over here, friend, I'll explain that to yourself. Just give me 2 minutes, friends. Take this example. I have got a file, let's say hypothetically of 110 MB. That can't go inside one. So whatever might be the size of the file, I have got 11 records. Whatever is the size of the file, I have got 11 records inside that. Okay. Now, the size of the file is such that it is spanning 3 blocks. So it should be 128 MB plus 128 MB and a part of it, whatever might be the size of the file. Okay. That is what is my hypothesis here. You see there are 3 blocks. Okay. Now within those 3 blocks, okay, I need to identify what is a split. So what did we say? The blocks split is what is by default the input split. Yes, that's correct. Okay. So what the mapper will do, it will create one mapper. How many mappers will be here in this example? There will be 3 mappers over here. But while the first mapper is doing, it can process 1, 2, and 3, and 4. But look at what happens at 5. Half of the record of 5 is there in the first one and half of the block of 5 is there in the second one. So what will happen in such a case is it will request the second block to pass on the remaining part of the data to the first one and it will be processed by the first mapper. That is what would happen in the case of the record number 5. Similarly, your second block would start from 6, 7, 8 and then 9. Half of the record of the first block is there in your second block and the balance part of the records of the data is in a third block. You'll request the third block to pass on that part of the record to the first block and then it will do it. Am I supposed to write a code for it? No. It will automatically be taken care of by the framework. So that's what we are saying. Logical records do not neatly fit into HDFS blocks. Why? Because when did the HDFS blocks come into picture? When I wrote a file. Logical records are the lines that crosses the boundary of the blocks. The first split contains line 5 although it spans across the blocks. Now understood, guys? So good. Got it, Asif? What is the difference between an input split and a block split? Make sense? So Subrat is saying, I think as you tell, 5 part is having 72 MB and not 128 MB, right? Hey. My example of 200 MB can't fit over here because in this example, kitna block chahiye mere ko? 128 plus 128 plus something. Let's do a mathematical calculation. Give me one sec. Also 128 plus 128 comes to how much? 256. Let's assume it is a 300 MB block. Okay? So I'll give you an example of a 300 MB block. So let's go back. So this is going to be 300 MB. Okay, the file is going to be 300 MB. Block split will be 128 MB and 128 MB and 256 minus 300 would mean 44 MB and 44 MB. Okay, think of it that way. Does that make it clear for you and does that make life easy for you guys? If you think in that way. So 128 MB and 128 MB is in the first 2 blocks. Okay. Although the part of the block is across, the block split will be exactly 128 MB. Okay. The default input split will also be 128 MB, but then in cases where there's an overlap, the split would actually be the first 5 records, then the 9 records, and then the 10 and the 11. This slide, that is the reason why we kept this slide, so that it will become crystal clear. Good. So we have understood what is this. At the time when the data is coming in, I am putting it into the node. So input data is distributed to the nodes. Each map task work on a split of data. Very clear, right? Because by default a block split is what would be an input split. Of course there would be an overlap in case if half of the record goes here and there. That's again clear. The mapper outputs intermediate data. You know that. Guys, where is the intermediate data stored? I forgot. If you can recollect it for me. Where is the intermediate data stored? It is stored in our local file system in the data node. Then there would be a data exchange between nodes in the shuffle phase. Okay. The framework guarantees that all the value of the same key would go down to the same reducer. The reducer output is stored. The reducer output is stored back on the HDFS. Okay. So this is what is a complete end-to-end process. Yes, the reducer output is stored on the HDFS. That's correct, friends. Very good. So this is what the flow is. Pretty simple. Hey, there comes Annie. So Annie has been waiting around the corner. Hey, Danish was saying, please clarify the shuffle phase. Danish, we did this yesterday last time, right? I'll explain to you once again. What happens in the shuffle phase is all the values of the similar key across wherever the processing node, everything comes together onto one partition and the reducer will process it. Okay? Shuffling means passing on the mapper output to the reducer. That's right. But along with that, what is the default shuffling mechanism? The hash of the key, friend. Okay, so all the output will always be processed by one reducer unless you specify the number of reducers. Okay, So, hey, partitioning is related to hashing. That's right. Hash is the way, think of it like a hash code. What is hash? So, hash means if you wanted to identify deer, beer, all the similar deers will be grouped together, right? How did it group together? Because it found out the ASCII value of every code. Think of it that as hashing. Okay? Shuffle, isn't it the same as the group by class? Yes. It is similar to the group by class in your RDBMS, in your SQL. That's correct. So all the similar things gets grouped by. That's correct. And how is it grouped by? Based on the uniqueness. Got it, Anjan? Cool. So we don't know what is a combiner here because I haven't seen it. It will come down in this slide, friend. We are going to talk about combiners, Subrat. So Ajay was saying, if there is only one reducer, will the partitioning happen? If there is only one reducer, hey, one reducer will have multiple words in that file, right? That is all separate partitions. You wanted to have similar words on the count of it. It is one reducer which is going to output that file into HDFS. See, the shuffling phase and the partitioning phase is a part of the framework. Even if there is one reducer, there would be a shuffling and a partitioning happening so that the values of that, all the values of that particular unique key will go down to one partition. MapReduce programming provides a way for the reducers to communicate with each other. So the answer is no. Reducers run independently and in isolation. Individual tasks do not know the input source. Reducer tasks rely on the MapReduce, on the Hadoop framework to deliver the right input for processing. Fantastic, guys. So how does splitting of an input file happens? Very good. So here I am talking about how is the splitting going to happen. I am talking about record split over here. Okay. Good. Good. Most of you have got it correct. Nice. So randomly, no, nothing happens randomly over here. So that is out. We will have to specify it explicitly. No, in the first example, we did not specify it explicitly, Sai. So even if you don't specify it, it is by default. I just showed it to you. Text input format, right? So it is line by line. That's correct. So the right answer is line by line. Okay, you can decide how do you want to split it. So for Java guys, we will see that in our advanced MapReduce code about how does the splitting happens. Okay, make sense? Very good. Hey, Ajay was saying splitting of input blocks. Let me go back. Okay, see, it is not, yeah, you're correct. So Ajay was saying that maybe the question should be splitting of an input block happens. That would make it very obvious, right? So by default, splitting of, the moment you say input block and all that, it will be confusing. So in general, this is actually a certification question, Ajay. Make sense? By default, a file is splitted based on the block size, right? That is an input split. So by looking at the thing, this is a certification question, so this is what they have exactly asked. Okay, good, Ajay. Input file is first put into blocks, that's correct, and then you analyze it. You're correct. Technically, you're very correct, friend. Perfect. So now we have already seen a demo of our input splits. So that is nothing but our word count example. I'm going to walk through that code. Don't worry, guys. So let me do one thing. Let me go through the code now to see how your concepts are with reference to your the first code. Let's break up the code word by word. Let me get down into Edureka. Let me get into the VM. Let me have a look at the questions. There is something called as an input split. See here. Represents the data to be processed by an individual mapper. So how is this done? Typically through the input format. There is a file input format, then there is a combined input format, key value, nline, and you can create your own input format also. That is what is the meaning. Window, let me say gedit, and let me create a file. Let's call the file as 24jan. Sorry, gedit 24jan. No text, nothing. So I have opened up a file called as 24jan. Just give me a second. This is a sample. I think I did this word count last time. Did I execute the word count example and show it to you last time, guys? Okay, I did that. Okay. So let's go ahead and look at the this one. What I call. I've already done this. So let's look at the code itself. Close without saving. So I don't need that. I think I have done this. You know the end-to-end way of doing it. So the focus here is let's not waste time. Let's look at the code. Since all of you have done this, let's look at the code. I'll explain the code to you. Don't worry, friends. I'm going to explain the whole code to you. Fantastic. So very good. And he's finished off all the assignments also. Fantastic, Subrat. So now we need to look at the word count example. So let me quickly go down to the LMS, and it is available for us. Just give me one sec, friends. It is there in my, I don't even have to open up Eclipse. It is there in the LMS folder. Let me double click on the LMS folder so that all of you will have the same thing. Let me double click on the MapReduce. And see over here, all the different assignments, everything is over here. Heyman said, but do we need to know how to understand the code explanation when the program runs and how to debug? Yes, debugging is typically done through MapReduce, MRUnit. That is through normal debugging. You have to understand what the code is. Let me go down to the word count. That should be there in my... Where is my module? Too many things over here. So module 3 assignment, data. Yeah, there is a word count. Let me double click on this. Yeah, this is the word count problem. Is this the data set? Yeah, this is the data set. So if I look at module 3, SRC, in.edureka.mapreduce, word count .java. There we go. Thank you, friend. So let me open up this word count.java, and now I'm going to explain to you line by line as to what is happening. So leaving out the Java part, you'll have to import all the necessary packages and put it into it. You would know that. Now there are two ways of writing a word count. Okay, so guys, for people who are Java guys, you will have to look at in the same link what I had given earlier. There is something called as, just give me one sec. Come on, MapReduce design patterns. This is primarily for the Java guys. So look at this. Ideally, you would have separate Java files for a mapper, for a reducer, and for a driver. Okay, but in case if you want the mapper to be used only by your class that you are going to run, that is the time when you will have it as a inner class. Thank you. So this is the book about MapReduce design patterns. Yes, you can download it. It is there. Very good. So have this. Java guys, look at this. So if you look at the example, what are we doing over here? An inner class is required only when you want to tightly couple your code. You don't want your mapper to be reused other than this particular class. That's the time, Ramesh, when you would need an inner class. Got it? So this is actually an inner class. So you've got a class word count. Inside that I'm creating a class called as mapper. If I expect the map to be used in multiple separate jobs, then I should keep it as an external class. Okay, otherwise it's an internal class. Every mapper should extend the mapper class. This is key in, key out, value in, and value out. Sorry, key in, value in, key out, and value out. You are going to override the function called as map function. So let me go back and check. Go down to the MapReduce package. In the MapReduce package, you will have a class called as mapper class. And please read the documentation. See here, it is explained beautifully as to how the whole flow would happen. Okay. Here you could do that also, Subrat. Okay. Now if you look at this, see the framework first calls what? The setup method, followed by the map method for each key value pair in the input split. So who converts that input split into multiple records? That is a class called as record reader. Okay. So you will also have to understand a class called as, we said input split is nothing but 64 MB, right? Who is going to convert that into multiple records? Okay. This is what is a record reader. Very good. Thank you. So please do that, guys. This is going to be very crucial for you. So where is the record reader word? Look at this input split and see over here. Typically, input split represents a byte-oriented view of the input, and it is a responsibility of the record reader of the job to process this and present a record-oriented view. Record-oriented view is nothing but a key-value pair. Okay? So now if you look at, if you go down, it's explained beautifully. The word count example is there. There are 4 methods what you have in your mapper. You have got a setup method which is called at the beginning of the task. You have got a cleanup method which is called at the end of the task. And you have got a map method which is called for every key value pair. And you can even override run method. Okay, wherein if you are going to use any of the streaming jobs like running it from a Perl or a Python code, you will have to use the run method and not the map method. Typically, the map method is called once for every key value pair in the input split. So look at each of these documentation and have a look at it. Exactly. That's correct, Subrat. Okay. So now, once you get inside your map function, let me go back to the example. You take up every line, you break it up based on space, you loop through it, and then you set the values. What is going to come out of it? A key and the 1. So this is where the 1 comes. Then automatically the shuffler will ensure this is going to happen on multiple nodes wherever my data is. So if you take the same example of our 300 MB of data, this is going to happen on 128 MB, 128 MB and 44 MB. Okay, I don't have to write a separate thing to ensure what will happen if a half of a record is there in the first block and the half of a record is in the second block. No, the input split will take care of it. I don't have to write any code for that. Then comes the reduce function. In the reduce function, you simply aggregate all of these things. So the reducer is always going to do some kind of aggregation. And then the most important thing is your code about the driver. So if I would have been in your place, I would have tried to find out what is this configuration. I would have gone up and I would have realized that configuration is there in a Hadoop conf class. I'll go down to the documentation. I will go down to the Hadoop conf and try to understand what it is doing. So I go down to the package, I click on this configuration, and then you see over here, wow, okay, now I understood it. Configuration gives me access to the configuration parameters. You can say here, all key value pairs are specified in the configuration. Okay, it reads the XML files, and see over here, now I understood what is the meaning of final, what I wrote in a lot of the conf files, what I have seen. Okay. So this is the way how you should do it. You should go back and look at each of these things. Got it? So this configuration blank object to our conf. No, Subrat, this configuration reads the XML files and give it to the job. Okay? So this is what you should be doing. Perfect. So once you do that, let's go back to the code. So after creating configuration, we are creating a job. Now let's go ahead to the next level now. So now if you look at the next level of what we have to see, we know what is a mapper, we know what is a reducer, but we have to know what is the additional things that is there. So we also have got something called as a combiner and a partitioner. So what is a combiner? Combiner is considered as a mini reducer. That means combining does the reducing in the map phase. Okay. So let me go back to the earlier PDF file, module number 3 that we had ran last time. Let me go down to the Deer Beer River example so that it becomes very clear for you. What are we doing? So, if you look at this, now, are we not having, let's say, what are we doing in our mapper? We are saying car 1 and car 1 2 times, right? Would it not be better if I had said car 2 directly? If I had said car 2 directly, what would have been the benefit of it? One, where is this output of the mapper stored? In your disk. So let me go ahead and document it. So combiner gives you two benefits. One, it reduces the disk I/O since the mapper output is stored in the local, and second, combiner will reduce the network I/O. Okay, so this is what is the benefit of the combiner. It will reduce your disk I/O and it will reduce your network I/O. Exactly. So instead of saying car 1 and car 1, if you have done car 2, it would have been beneficial. Got it? So fantastic. So this is the way how the whole thing will happen. Hey, DP had a question. Where does shuffling happens in the word count.java? Shuffling, who controls shuffling, guys? I'm not talking about a pseudo cluster. I'm talking about a fully distributed cluster wherein you have got one machine for the mapper, or I mean one for the master, the name node, one for the secondary name, one for the active and the passive name node, one for the resource manager, and you have got multiple slaves. Let's say you have got 10 slaves. Who controls the shuffling? Shuffling is controlled by the application master. But where is it actually done? On the slaves. Okay, let me open up my day2.pdf. Sorry, my text document. Go down to the customers, go down to Edureka. Let me open up the document day 3. Let me see if there was some confusion in what I was saying. Let me go down. Shuffling, it will be controlled by the application master. Okay. So, actual shuffling is done on the slaves. This is all finished. So now, what is a combiner? A combiner is considered as a mini reducer. There is a slide which will tell you a little bit more about it. Let's go ahead and see. So, combiner is considered as a mini reducer. So, this is one of the optimizations what we have. Okay. So, cool. Fantastic. So now, in case if you are using a combiner, you have to do something specific. We will have a look at it. Then, what is a partitioner? By default, partitioning happens, right? How is the partitioning going to happen by default? It is going to happen on the hash of the key. That's what we saw earlier, right? So all the similar words are coming together. But in case if you want to control your own partitioning, you can even do that. If you want to control it, you will have to write your own partitioner. So when will I use my own partitioner? So Hemant, this is where your question of group by comes. Okay, the default group by is based on hash. In case if you want to group it on something else, you would use a partitioner. So partitioner determines which reducer is responsible for which particular key friends. Okay, so that is your concept of your partitioner. So we have seen what is a combiner and partitioner. We are going to see an example of it as we go ahead. So see over here, combiners are considered as mini reducers. Why? Because they reduce the work of your actual reducer. This is done before the workload is passed on to the reducer. They do a local reduce on the map side. So wherever the mapper is running, combiner would be running over there. And this is done before they distribute the map results. So what happens, instead of saying car 1 and car 1 2 times, you can actually do it as car 2. That is what is the significance of the combiner. And this slide should make it very clear for you. So here you have got 2 blocks. See how similar words are there. If I had not used the combiner, all of these words as it is would be gone down to the actual reducer. Okay, So in case if this combiner is there, you see the similar words are brought together. Okay, so you see your B is happening 2 times, D is happening 2 times on the first block. Similarly, D is happening 2 times and A is happening 2 times on the second block. So combiner does a mini reducing on the mapper side so that your disk IO and your network IO would be reduced. Okay, fantastic, Subrat. And then, of course, there will be a shuffler that will be there after that. So what does a shuffler do? It brings together all the similar keys together of your node. So in this example, what would happen is whenever there is a shuffler, whatever are the values of the similar key across both those nodes are brought together. So in case if you want to do a custom grouping, here A, B, C, D, E is together. If you want A to C to be there together and then D and greater than D to Z to be there together, you would have to write a custom partitioner. The partitioner would have got together all the values of A to C together. That is what is the group by clause. Okay, and then of course there would be a reducer which will do the aggregation of the values of whatever is coming through. Okay, let's move on now. So hey, there comes Annie. So combiner works at what level, friends? 1, 2, 3, 4. Where does the combiner gets executed? Since it's called as a mini reducer, it will be executed at, it is going to be executed at the mapper level. Okay, so combiner works on the output data from the mapper. Very good. Next question. Combiner can be considered as what? Good. 1, 2, 3, 4. Good, good. Most of you have got it correct. Of course, it is considered as a semi-reducer. There is nothing called as a semi-shuffler or a semi-partitioner. It is always called as a semi-reducer. Very good. So, combiner works on the mapper output and reduces the burden that you have on the reducer. Fantastic, friends. There we go. So, now we have seen what is partitioner earlier. Okay. So what is the default partitioner? Hash partitioner. So the partitioner decides, okay, the output of the mapper, how will it go to the reducer is what is decided by the partitioner. Shuffling is done based on the partitioner logic. Okay, good. Hey, Hemant had a question. One basic question is, the combiner happens on the same node unlike the reducer? Exactly. The combiner happens on the node wherever the mapper is running. Okay? Combiner does not happen on the node wherever it has not even reached the reducer. So that's the reason combiner happens on the node wherever the mapper is. Cool. I hope that makes it clear. So now, what is the default partitioning mechanism? Hash. If you want to write your own custom partitioner, even you can do that. Okay, perfect. Good, Hemant. So, in case if you want to do it, there's an example which will tell you how to do this. Let's move on. So, see here, this is a very interesting question. So, can we use the same logic for the combiner and the reducer? Okay, yes or no? Of course, the answer is yes. Okay, hey, the answer is yes, because it's a mini reducer. You can use the same logic for the combiner and the reducer, but there is a subtle difference that is there which we want to bring it to you. You can do this only if the logic of both of them are commutative and associative and both of them have the same data type. In many cases, your mapper output would have a different data type and the reducer output would have a different data type. So, if that is the case, if the data types are different, then you cannot use the same code. Otherwise, in most of the examples, it will be the same. So, you can simply reuse it. Exactly. That's right. No, Subra, this is the other way around. You can use your reducer as a combiner. Okay, so because if you look at combiner, there is nothing called as a specific combiner class. Combiner class will always extend a reducer class. Okay, So there is a method. Let me go back to the documentation and show it to you. So if you go down to the documentation and if you go down to the job class, what you have in your java.org.apache.hadoop.MapReduce, if you go down to that and if you select your job class, in the job class there is a method called as setCombiner. Let me scroll down and show that to you so that it becomes very clear. So there you see. So what is the class extending? The class is extending a reducer class, right? So that's the reason how the combiner can be considered as a mini reducer. So it is a job.setCombiner class and you specify your reducer class. That's perfect. Okay, cool. The same code can be done, but then you just have to be careful and ensure that the logic of both of them is the same and they have the same data types. Okay? If the logic is different, then you should create your own custom combiner class, which is of course going to extend the reducer class. Very good. Good, Subrat. There we go. So the right answer, what Annie says is yes. If the logic is the same and both of them are the same data type, I can use it. So now, in case if you want to see a code of the combiner and the partitioner, we are going to see it right now. So let me go down to the blog, and that's something that you'll have to actually do hands-on. Let me go down to my LMS, and let me go down to my module number 4. Let me expand this. If you look at your module number 4, okay, there are more examples. So Himanshu, you were asking me, can I use this only for what you call only for understanding word count, or can it be used somewhere else also? See over here how it can be used for calculating max temperature, finding out the hot and the cold areas. And if you look at the assignment solution, what we have, if I download it, I've already downloaded that. So if you look at this module number 5, we were there in, sorry, module number 4. Do I have the module number 4? No, one sec. Let me go down to module number 5, advanced map, no, not this. It is there in module number 4 itself. I haven't downloaded module number 4 over here, guys. Hey, there it is. Module 4 assignment solutions. If you look at this, I've already downloaded this, and if you look at the SRC, you would have examples of what am I going to show right now. Okay, you have got the de-identify data Java, that is a healthcare example that we're going to talk right now, the max temperature and the weather data set. Okay, so this is the example which will have everything what I'm going to cover up right now. So from where did I get this? Please download this assignment solution of your module number 4, my dear friends. Okay. So let's continue. We are going to talk about what is a combiner and a partitioner. So this is the healthcare data set what you're having. So this is the healthcare data set which has got a column for identifying the ID, some further details, some date, some email, some other information, then the male or a female, the sex column, what is the disease that the patient had, and his age. Okay, so this is what is there in the healthcare data set. So typically, if you look at the healthcare industry, the biggest challenge what the industry has is how do I de-identify the personal information from the data set. Okay. So I have got the data in my relational data store. So just one sec. So via Scoop, you have taken a dump of that data. Okay, you did some pre-processing. Remember, we had spoken about the matches column, and then you put that into your HDFS. Then in your map task, you will read the comma separated value file from HDFS. You will write your business logic of whatever columns you want to de-identify. The output of that would be reduced and store the de-identified file into HDFS. Okay, so this is what is the de-identification architecture that we had earlier. Okay, so now this is what is going to be the de-identify MapReduce code. So the earlier code that we have discussed about the combiner partitioner example, that is something that we are going to cover it up in our advanced MapReduce. If you look over here, if you look at your module for advanced MapReduce program codes, once you download this, or not download, it will be there in your LMS. You have a folder called as combiner partitioner. So we will be touching base on the combiner partitioner example when we talk about our advanced MapReduce. So let's walk through the MapReduce code for the de-identification. Fantastic. Great, Subrat. So let's go ahead and actually see that. So if you look at the de-identify MapReduce code, let me go ahead and open up that particular code for you. So if I go down to module 3 assignment solutions, let me go down to SRC in Edureka MapReduce. Let me open up my de-identify.java in an editor. So let me send this to a simple tool called as Edit Plus. See over here how we have got, let me do a word wrap so that it will come in one line. So you have got a map class. This is a de-identify.java. You have got a map class. Then you have got a logic for that. Then in the main, you are seeing how to work with it. Okay. There is the business logic of encrypting in a class called as encrypt, wherein the business logic is mentioned over here. What all jar files are needed over here? What all jar files are needed over here would be there in the lib folder, friends. So if you look at your, let me go back to the folder, go back. If you look at your lib folder, any additional jar files that is needed, that is there in a file called as common codec-14.jar, it is already available for you. Okay, so don't worry, this is a complete example that you can try it out, and you should try it out as a part of your assignment of today. Okay, let me go back. So in this de-identify code, what are we doing? We have got some logging classes. So what is this logging classes is? Logger is basically if you want to log out something, you would need your logger. Log is if you want to print out your statements to go down to some file, that is why we will be using our logger. In the map class, what do? We are picking up the whole record. So let's go back and see how many columns we had. We had in our data set 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 columns. Okay, I need to find out whether they're using the first column or not, but I had 10 columns over here in my data set. Hey, Madhur was asking me, sir, where is the files in the LMS? The files are there in the LMS in your folder. Let me go back and quickly show that to you. So you would see that it is there in your MapReduce module for assignment solution. If you look at a module for assignment solution inside your Edureka MapReduce, you have this de-identify.java code, friend. Okay. So you have this in your VM itself. Okay, friend. Now let's continue. So how do I split all of these things? I split it based on comma. So I'm using a string tokenizer based on comma. Okay, so I am putting all of that. I'm creating a array list of type integer. Okay, and then what am I doing is I'm writing some sysout statement, and I am going to list 2, 3, 4, 5, 6, and 8. Okay, so those are the columns that I am going to list it. You'll see it in the code as we go ahead. This is what is. So what do you mean by de-identify, guys? I want to wrap away or show all of these values as encrypted fashion. I don't want to show them the actual values because I don't want people to know what are the customer telephone number, customer name, the patient telephone number, patient name, his email address, his age and all that, right? So I wanted it to be hidden. So that is what we are doing in our code over here. Good. So then what do? We loop through those values. Okay, and if it contains some value, you are going to encrypt it. So what is this encrypt function? This is one function which will take a string and it will encrypt the value. That's what we are doing. And after encrypting, you are again the output, whatever you are pushing is a null, and you are putting in the text as the value. Okay, so encrypted data is pushed out. That is what is this logic of the code doing. So see here in the main class, what do? We set your output class as null writable. The value class is going to be text. We only have a mapper here. There is no reducer here because we are not doing any aggregation and we are only de-identifying your input data. So a lovely example where there is no identifier. So when I said demo of the de-identify program, what I expect you to do, guys, is this is the Java file. Make sense? Cool. So please try this example, okay, so that you will understand how the whole execution would happen, guys. Sure. So Ajay, you can create your own sample file, but then please remember the order of the parameters. The parameters should be important. Please have the parameters as per the value. Exactly, Ajay. It will encrypt. Okay, fantastic. Please do that. It will definitely do that, friends. Cool. So let me go back to my PDF. So this is what the code is all about. Okay. So now, in case if you want to get the next example, that is the weather data. So this is the location from where you can get the weather data. Okay, we are having some examples. So from where do I get the weather data is over here. So you can pick up this weather data. Okay, good. So this is talking about the JavaX security. So this is a standard code wherein using a base 64 API you can do your encryption. This is a standard code which you'll easily find it on the internet. So you are doing a cipher, you are creating a key over here, and then you are whatever value that you are encrypting, string that you want to encrypt, you are encrypting it as per the binary key. So let's continue. So once you download the data from your weather data, you can actually do that. So when I say demo of this, I expect you to actually do the weather data. This is the Java code. This is all a part of your assignments, guys. So go back to your LMS. See over here, you are supposed to calculate your maximum temperature. So the data set for the maximum temperature is here. You're supposed to find out the hot and the cold dates. Okay, the data set is available over here. The assignment solution is also here, but then please don't look at the assignment solution. Try to see if you are able to do it on your own, friends. Okay, so that is what is this module all about, guys.